Question 14 A was as follows. The diagram shows two lines L and N that are perpendicular to each other. The equation of the line N is 3x plus 2y is equal to 6. The line L passes through the point 5, 4. Okay, so what you need to do is you take time and study the diagram. Then the question is here down. The question is here down. This is the question, which is find the equation of line L. So we are asked to find the equation for line L. So basically what is here is that we are just given the equation for the line N, which is this equation, which is 3x plus 2y is equal to 6. And line N is the one in green. And we are supposed to find the equation for line L, which is a red line. Okay, so or a lady graph. Okay, so what we need to do now here is we need to first find the gradient of the line L. So to find the gradient of the line L, what we're going to do is we're going to use the equation that is for L. Remember, these two lines are perpendicular. So since the lines are perpendicular, that means we need to find the we can use the line, the green line, to find the gradient of line L. Okay, so what we're going to do is we're going to use the equation that is 3x plus 2y is equal to 6. Then what we're going to do here is we're going to make y the subject of the formula. That means we're going to write 2y is equal to 6 minus 3x. Okay, now we need to make y the subject of the formula. That means we're going to divide all these three terms by 2. So we're going to divide 2y by 2, 6 by 2, and 3x by 2. Then once we've done this, that means now we can say 2y divided by 2 will give us y. 6 divided by 2 will give us 3. Negative 3x divided by 2, that will be negative, it's going to be negative 3 over 2x. Okay, now at this stage we can now get the gradient. So the gradient for the first equation is negative 3 over 2. That's a gradient. Now from this gradient, since we are told that the line line L is perpendicular to line N, what we can do now here is we're going to now find the gradient for line L, which is we're going to write gradient 2. We're going to call it gradient 2. Then we're going to write the inverse of that. It's going to be 2 over 3. Okay, so the gradient for the red line is 2 over 3. That's a gradient. Now once we've found the gradient, what we're going to do next is we're going to use this formula for the equation to find the equation of the given line. So we're going to use that. Okay, so let's now start filling in. So we have got y. We're so going to write y is equal to, then we're going to get the gradient. We're going to get gradient 2, which is 2 over 3. We're going to say 2 over 3, then x. Then what is the value of c? We do not have the value of c. So what we're going to do is we're going to find the value of c. So I'm going to write this same equation here on the right side in yellow. I don't know if it's orange. In orange, yes. Then once we've done that, then what is the value of y? So we are given the coordinate where the line is passing on one point. We are given here where the line is passing, and you can see also in the statement it's given there. Okay, so those are the two coordinates we're given. So we're going to use those. So what is the value of y in those? It's 4. So we're going to write 4 y is equal to, or 4 is equal to, then the gradient we found is the second gradient, which is 2 over 3. So we're going to say 2 over 3 x, what's the value of x? Is 5. So we're going to say multiply by 5 plus c. We don't know the value of c. Like once we've done that, then we're going to evaluate 2 over 3 multiplied by 5, which will give us 4 is equal to 2 times 5 will give us 10, which will be over 3. Okay, then we'll say plus c. Okay, now at this stage we're going to put like terms together. So we're going to write 4 plus, so the 10 over 3 will cross the equal sign and go to the side of 4. That means it's going to be minus 10 over 3, okay, which will be equal to c. Okay, now once we have done this, the next thing we're going to do is we're going to convert 4 to become a fraction. So we're going to have 4 over 1, then 4 over 1. Then what we're going to do is we're going to subtract fractions. So I'm sure you know how to subtract fractions. If you don't know, you can go on our playlists. You'll find a topic called fractions. You will learn on how to subtract fractions. So here what we're going to do is we're going to find the lowest common denominator of the lowest common multiple of 1 and 3, which is 3 itself. So we're going to say over 3. Then we're going to get 1. We have got the first fraction, which is 4 over 1. So we're going to pick 1. 1 into 3 to go 3 times. So we're going to multiply 3 by 4, the numerator. Then we're going to have minus. Then we're going to say 3, the denominator of 10 over 3. 3 into 3, it will go 1 time. So we're going to multiply 10 by, so we're going to say minus 1 by 10. Okay, which is equal to c. Then what we're going to do now, we're going to evaluate that. 3 by 4 will give us 12, which will be 12 minus c. 1 times 10 will give us 10. So I'm going to write 3 by 4 will give us 12, then minus c. 1 by 10, it's going to give us 10, which will be over 3, which will be equal to c. Okay, once I've done that, then I'm going to evaluate 2 minus 10 will give us 3. Oh, sorry, not 2, but 12 minus 10 will give us 2, which will be 2 over 3. Okay, then which will be equal to c. So the value of c is 2 over 3. So we go back on the middle, on the paper there where I left the equation halfway. So where the second step there where I wrote y is equal to 2 over 3 x, then we're going to say plus 2 over 3. So this is the equation for that straight line, the L line, the red line. That is the equation for the red line. So you can write that equation on your answer space, or you can go further and simplify this thing, this equation. So what you're going to do is to simplify that one, you're going to multiply every term in that equation by 3. Okay, so we're going to have 3 by y, 3 multiplied by y is equal to 2 over 3 x multiplied by 3 as well, multiplied by 3, then plus 2 over 3 multiplied by 3. Okay, so now let's start evaluating. Let's start from the left side. 3 times y will give us 3y, which will be equal to, then we come here where we have 2 over 3x multiplied by 3. So the 3 down here will be cancelled out, and the 3 there on top will be cancelled out. Okay, so that the 3 there which is down, it's okay, it's supposed to be like that. So what are we remaining with? We're remaining with 2x, so we're going to write 2x. Then we come to the last term, which is 2 over 3 multiplied by 3. So 2 will become 3 will down will be cancelled out, and the 3 on top will be cancelled out, leaving us with only 2. So it's going to be plus 2. Okay, now that is the equation you can also write. So it's either you write this equation here, or you can also write this equation. both of these equations are correct. They will definitely going to give you correct answers if you use them. Okay, so basically these are the answers you can write, and these are the answers examiners were expecting, either the one on top there or this one down. Okay, so if you have got questions, you can ask in the comment section. Otherwise, let's go to the next question. Question 14b was as follows. The diagram below shows a triangle ABC in which AB is equal to 5 centimeter and AC is equal to 13 centimeter. Angle ABC is equal to 90 degrees and BC is produced to D. Okay, the question is find, so the question is here, which is find the value of cosine of angle ACD. Okay, so ask to find the cosine of angle ACD. So before we go ahead to find the cosine, first let's talk about the formula that we can use to find the cosine. So we're going to say cosine for angle ACD is equal to, so what you need to do for you to come up with a correct ratio, what you need to do is first you need to consider this one, which is called SOHCAHTOA. So you need to consider SOHCAHTOA. So is for sin or sine, and ka is for cosine, and to is for tangent. Now, when you look at this formula, we are going to concentrate on this one, the acronym which is in the middle here. Sorry, which is here. Okay, which is ka, which is telling us that cosine, the formula, the ratio for cosine is tangent over it's adjacent to over hypotenuse. So we're going to say the ratio is adjacent over hypotenuse. Okay, so once we have come up with this, now we can go on the diagram and identify the angle which we are going to find the cosine for. So we're going to identify the angle, which is this one here. This is the angle. Okay, so this is the angle. So when we look at this angle, when we try to identify the adjacent, the hypotenuse, you'll find that it's very difficult to identify the let me say it's just impossible to find the adjacent and the hypotenuse of this angle, because as you can see, it is an angle which is in the incomplete shape. There is no shape on the other side. So how do we find the cosine for this angle? So what we're going to do is we're going to find the cosine for this angle by using this angle, the inside angle. Okay, so we're going to use the inside angle, which has the lead arc, to find the cosine for the angle which has a green arc. Okay, so how do we do this? So what we're going to do now is we're going to find the cosine for this angle, the inside angle, which has a red arc. So what we're going to do is now the angle I'm talking about. So to find the cosine of this angle, we are going to use this inner angle, okay, to find the hypotenuse of the angle which is outside. So how are we going to find this? We are going to use the same formula, which is cosine of angle ACB, cosine of angle ACB. You can see that that angle is angle ACB, which is equal to adjacent over hypotenuse. Now, when you look at this angle, which side is adjacent? The side which is adjacent to that angle is this side, which is BC. BC is adjacent to angle ACD. Okay, so this angle, as you can see, we are not given the dimension. The measurement of this length is not given, so we are going to name it x. Okay, which one is hypotenuse? So the hypotenuse of this angle is this one. This is the hypotenuse of this angle. So what we're going to do now here is we are going to find the value of x so that we can be able to find the cosine of angle ACB. So what we will do now is we are going to use the Pythagoras theorem. Now it's going to work because this is a light triangle, so which means the light triangle is, which means that we can use Pythagoras to find the value of x. So we are going to work for x, which is we're going to write hypotenuse squared is equal to adjacent squared plus opposite squared. Okay, so what we're going to do now, we're going to put the values. So what is the value of hypotenuse? We know that it's 13 centimeter, so it's going to be 13 centimeter squared. What is the value of adjacent? When you look at the adjacent, you find that the value is not given, so we have got x there, so we're going to say is equal to x squared plus what is the value of opposite? Opposite is 5 centimeter squared, so we're going to say plus 5 centimeter squared. Okay, then we're going to find the value of 13 centimeter squared. So 13 times 13 will be 169 centimeter squared, which is equal to x squared plus 25 centimeter squared. Okay, now once we've done this, the next thing we're going to do is we're going to put like terms together. So we're going to have 69 centimeter squared, then 25 centimeter squared will close the equal sign and become minus, so it's going to be minus it shouldn't be 12 centimeter, it should be 25 centimeter squared. Okay, then what we're going to do now here is which is equal to x squared. Okay, x squared. So here I don't know what happened when I was preparing to write 12 centimeter, it should be 25 centimeter squared, so I'm going to change it later on. So I'm going to say then it's going to be 169 minus 25 centimeter squared is equal to x squared. So when we subtract 169 minus 25 centimeter squared will give us 144 centimeter squared, which is equal to x squared. Okay, now at this stage what we're going to do is we're going to find the square root of these 144 centimeter squared and x squared. So I'm going to find the square root. So the square root of 144 centimeter squared is 12, which is equal to x squared, or sorry, the square root of x squared is x. So the value of x is 12 centimeter. Okay, so now that is the value of x, which is 12 centimeters. So what we're going to do now here is we are going to now find the cosine of angle ACB. So the cosine of angle ACB is, so what is the adjacent? So we're going to say equal to what is the adjacent of angle ACB. The adjacent is 12 centimeter, which is going to write 12 there, which will be over, then what is the hypotenuse is 13. Now 13 over 12 is the cosine of angle ACD. Okay, so now we need to find the cosine for angle ACD. We have found the cosine for angle ACB. Now we need to find the hypotenuse for, we need to find the cosine for angle ACD. So we're going to go back where the cosine for angle ACD is. So we're going to write equal to, so what happens, the outer angle of the given angle, the cosine of the outer angle of the inner angle, the cosine we find, we're going to write it in a negative form or in an opposite form. So if we can say, yeah, if like we can say it's we write the additive inverse of the given cosine. So like here we have gotten 12 over 13, so we can now come up with negative 12 over 13. So that is the cosine of angle ACD. Okay, if you have got questions, you can ask in the comments section. Otherwise, that is the answer we are supposed to write, which is negative 12 over 13. Oh, yes. So here where I wrote 12 minus 12, here it was a mistake. It's not supposed to be minus 12, but it should be minus 25. So that's how it should be. Otherwise, the answer, which is 12 centimeters is equal to x, is correct. I only just made a mistake on writing. Instead of writing 25, I wrote 12. So that's how it should be.